there, welcome back to my tutorial. So this is a continuation of the video that I started that I was running out of time that I had to end it. So this is a part 2 of the manipulating those images. These are the basic operations I expect you to know if you really want to do image processing in Python. And so for this particular video, I will be completing the basic operations by showing you how to convert from one color space or rearrange the color channels in your image. And so basically moving from BGR to RGB, but also converting the type. So moving from unsigned integer 8 to float, for example. And then I will show you how to rotate images, how to add text to the image, and maybe also how to add object depending on how we're doing time-wise. And so here in my notebook, I've already started coding, and then figure out I should do the tutorial alongside. Okay. And so yeah, I'll just import the basic stuff that we need for this tutorial. I've already explained this over and over, so as I'm using them, I will be explaining what they're doing. So I'll run that cell, that's true. And then next I provide the path where my image is, which is in this folder, and there's an image called ucon_everypoint.png. This is the string, so I just get that string, and then the next line of code I use the OpenCV that I imported here to read the image. So this is just the path of the image. And so after this, I should have my image loaded, and this would be, if I do the shape, I check the shape of this image, this would be a 3D because we have the height. These are the pixels in the height in the Y direction, the pixels in the X direction, and it has 3 channels combined together. So it has the blue, the green, and the red. That's how it's arranged because I'm using CV2 to read. And so the first is, let's just visualize what we just loaded. So that particular image, if we visualize that, this is how it looks like because I'm loading with CV2 and I'm plotting with Matplotlib. You see that it's looking weird. Again, if you want to select what is showing here, you just have to do an underscore equal to, so that's a handle, and that will go away. Okay. And so to take care of this, we have to rearrange how we loaded the image into the way Matplotlib expects a 3-channel image to be organized. And that's what I do in this particular one. I just convert it from the way OpenCV reads the image into the way every other package will expect the image for plotting. And so we'll move the red channel to the front rather than keeping it at the back. And then the green is still in the middle, and then we'll move the blue to the end. So instead of BGR, it's now in RGB. So R is the red, G is the green, and B is the blue. And so to do that, we just have to do OpenCV.CV2 color, and then we'll do it in the image that we want to operate in. Remember, that's the image you just loaded here. And then we just do the color conversion. So we just tell it color, and it should go from BGR, which is a native way of reading it, into an RGB, which is what we want to achieve. And so we're calling this particular image our RGB image. So if I run this now, if I check the shape of this, and my original image will be the same. But if I plot it now, so I'm plotting this, I'm not plotting the original image again, the one that has been worked on, it will look like the way my camera snapped it. So this is how the image that was like this is actually is. So this is the ocean, it's a lighthouse, there's a cloud, there's a sky, there are clouds there, and then there's grasses, and then there are borders. So that's just how the image is. And so that's how you convert from one space to the other. You could always convert that back to the way OpenCV had it if you want. The next thing I want to show you is how to manipulate between the different data types. And so we'll be converting, like if we check the type of this particular image now, since we have already started using this, since we've converted to this, let's just check this. If we check the type and pass in this will tell us that this is a NumPy array actually. But if we print out the values at the end, it will tell us the type. So this is an unsigned integer 8. This is the type is an unsigned integer 8, and you can see the values. The maximum value in this array will go to 255 actually. right? And we want to convert this so that it goes to only 1. So what we have to do is to change this into a float, and that's what we want to do here, this float image. So we're moving from this unsigned integer 8 into a float. And to do that, we're going to use scikit image. In scikit image, there is that particular function. In scikit image, there is this image as float, and there's also image as ubar. This will allow us to like convert it back if we want to convert it back actually. And so with that said, let's remove that. And then if we run this line of code, this will give us this. The shape remains the same, but if we like print these values now, then the maximum here is 1. So if we do the maximum of this particular image, and one way to see it is add color bar. So if we do plt.color bar on this particular image, and let's copy this to see that it's going to this 255. Okay, don't mind the colors on the bar, so I'm just using it to show you those values. And if I copy the same stuff here and paste it here and check what is this unsigned integer 8, what it looks like, then we could see that it's going to 1. So on the color bar, we see that it's going from 0 to 1. So the dark side is 0 and the bright side is 1 rather than that. So I successfully converted from this space into that space. You can always take it back if you want by using the u by 8 that I showed you earlier, but I'm not showing that in this particular tutorial. The next thing I wanted to show you is how to rotate images. To do that, you just have to, I clicked something somewhere. To do that, all you have to do is to perform this operation. I already have the code. I'll paste it here and just walk you through how to do it, so we don't take forever time. Again, if you're not clear on anything, please drop it in the comment section and I will respond to it. And so to rotate the image, you just have your image. In this case, we'll grab the shape. Remember, this is a 3D image, so we're just picking the first 2. That's just what I'm doing here. Let me just split this and just run it and show you what I mean by that. And so if I add an additional cell and just print this straight to the screen, it's just grabbing the first part of the shape. So I've been doing shape since. What we're just basically doing is we're grabbing these first 2 of the image. So that's the first step. And we want to get the height and the width. That's why we did this. And we have successfully done that. Now we have the height and the width. Next is to find the center of this particular image. Since we want to rotate it, we want to have the pivot to be at the center. And to do that, we just have to pick our width and flat divide it by 2. This double slash, the way of dividing it ensures that you have a whole number as a result. And so it's not a point something something. So if we divide this number, in this case, this will be fine. It will give a perfect whole number. But in some cases, if we divide a 3 by 2, it will give a 1.5. And so this double will just make sure that you just get a 1 at the end. So you just pick the integer. So for example, if you say 3 divided by 2 this way to give a 1 instead of 1.5, that if you do this, you get. Okay, that's a little distraction, but it's good to explain some of these little stuffs. Okay, and then we'll do the same thing for the horizontal. Now we have the center coordinates. So if we run this, we'll check the center to give us the coordinates at the center of this particular image. That's great. Next is to do some rotation metrics, and to do that, there is already standard package in OpenCV called the Get Rotation Metrics 2D. And so we just have to provide the pivot point, in this case the center of the image. We could do it in the lower left as 3000, this as the values, or we could do it anywhere that basically we want to rotate the image around. But in this case, we choose the center, and then we just provide these 2 other arguments, which is just the angle of rotation and the translation kind of stuff. And then we could just rotate the image now using the cv2.wapafine. Affine is something that relates it's a way of applying the rotation and translation metrics in Python basically. And so we just pick the image, which is this image that I want to rotate, and apply this rotation metrics that we generated here, over this and the size of the image. So this is just the shape of the image. And if we run this particular code, it will run, of course. And then if we plot this image, let me just copy this particular image without the color bar and paste it here and do the rotating instead of the float, and you could have a look at how it looks like now. So there we go. So we have successfully rotated this image by 45 degrees. You could change this angle and see how it looks like. You could change this to maybe make it to go all the way to 95 degrees, not 90. And that's how it goes. It went up and then change the other way. So you could spin it around anyhow you want. 135. It will go all the way and make like almost a C. Yep, that way. So that's how to rotate images in Python. Let me know if there's any confusion. The next stuff that I wanted to show you is how to add text to images in Python. To add text, you just need this. I also have the code already, so I'll just explain what I'm doing. So first, we just make a copy of our image. We're just making a copy so that we're not modifying the original. And now we'll call this a text image, which is the image we're going to add text to. And the text we want to add is hello. Let me just put my name there. I was trying to be more generous, but maybe it's good for you to know my name, Bernard. And so I want to put a text, so there's a command called put text. So in CV2 there's a put text, and the text, you provide the image to which you want to apply the text, and you provide the text they want to apply, and you provide the position you want to apply this particular text. And these are the important stuff. The rest are, you don't have to worry about those ones. So in this case, it's telling us the vertical, the horizontal position to where this text to go. And then the rest are just guiding on the font size and every other stuff. So with that, if we run this now, I was going to silent that. To silent that, I just have to do underscore equal to that, so it doesn't print. And then we could plot this particular image at this point. Let's just copy this rotated image and plot the text image, which is the image that will have my name on. Remember, it's not the rotated, so don't expect to see the rotated stuff. So it's right there, but the font is really tiny. But get the idea. You could zoom in. If you have big eyes, you could see it there. I don't want to show you how to manipulate text at this point, but just know that it's there. Great. And the final thing I wanted to show you in this video is to add an object to the image. So to do that, we use this particular code. You just have your original image. We'll make a copy again. To make a copy of an image, you just have to do .copy. And we'll call this a rectangle image. That's the image we want to add a rectangle. And this is the position that we want to add the rectangle. And this is how the rectangle dimension looks like. That's like the gap in x, in y and x. Notice that they are not the same. If they are the same, that will be a square. And then we'll just provide other thickness, plotting thickness stuff, and the range. And so if we run this particular one again, we could silent that by doing underscore equal to 1, and then let's copy this image and plot it right there, and we should be able to see this rectangle in the image. If we run that, and then that's all for the day. And it's going to be tiny. It's right at the top there at 50,50. You could move it around to say 1000 by maybe 150 in that direction. And this combination is for the color. I forgot to mention that this is for the color. So now we're just using a green. If we give it this, remember it's an RGB. So if we give this R, which is a red, a 200 for example, then the color will change from green to another thing. So when you have a green and a red, what do you have? That's what you have. Okay, this is like 150, and I'm just getting like a straight line, which is weird. Okay, let's do that squared, and that's it there. I wouldn't stress you too much about this, but if we change that to 400, then that's how it looks like. You always, yeah, play with that and see how to extend these dimensions to maybe 400 in that direction and 100 in the other one. That will make it bigger. You could place it in the middle wherever you want, but that's how you get it done. You could also add a color there, maybe just 30, so that it's not perfect greenish, but that's it. So that's how to add objects. So that way you can mark a section of your image that you're doing analysis upon. So suppose you want to analyze here, you will need something that looks like this bounding box around that region, and that's how you fetch those coordinates and add. Hope this video is helpful. This code is available on my GitHub. You could go there and grab it if you want. See you in the next video. Bye. Please like, subscribe, and share.